Hi everybody, today we are going to be talking about slope, so I'm doing your slope notes right now. I'm doing it during school, so if you hear people outside, that's why. If you hear a bell ring, it's because it's right before 6th period, so did it right after I saw you. So let's go ahead and get started with some vocab. I apologize for the long notes. Slope is a really important thing. It's also a really easy thing to do because you guys have already done slope before. So it's just going to be like a lot of practice for these notes, and what we're going to do is we're going to practice it some more in class. Now, slope is really important because it's a big deal in algebra, so we're going to make sure you guys are 100% on this. Sorry, like I said, I'm still in school. So let's go over vocab. So slope is the ratio of the vertical change to the horizontal change between points, okay? And rate of change is another name for slope. So this stuff should not be new to you. Some of the stuff might be a little new to you just because you've never seen it before, but definition all mean the same thing. Okay, you'll probably only ever see rate of change if it's like you'll see it and you'll need to know what means slope. A lot of times it's used in real world problems versus anything else. So, but slope can be expressed as, these are the formulas. Rise or run, which is probably the thing that you know best, which is fine. Keep it, okay? Or it can be represented as m equals y2 minus y1 over x2 minus x1, where the 2's and the 1's are just representing the different x's. So y2 and x2 are from the second point, and y1 and x1 are from the first point. So they're not like exponents or anything. So this is more what you see in algebra. And I have this poster with this formula on my wall, so if you want to look up and see it, you can. But if you just know rise or run, you're golden. And the last thing is the vertical change over the horizontal change. This is more for higher level math, like where they have the abstract concept and everything. They just know that. If you got rise or run, you're good. If you got this one, you're golden. And this one, who cares? Because all I care is this one. Okay? So let's go ahead and talk about the different kinds of slope. So there are different kinds based on the way the line is drawn. A negative slope is when the line is being drawn down from left to right. So when you look at it, it looks like you're going down a roller coaster. Okay. Positive is when it's drawn up, going from left to right. So it looks like you're going up a roller coaster. Undefined is a vertical line going up and down. And zero is a horizontal line. Like, if you're in a car, you're having zero fun compared to a roller coaster, right? So, whereas undefined, if you're in a car, you're falling off a cliff, basically, and you're not having any fun. You're not having any fun, and you're not doing anything. So, there's a way to remember this. These are all on my board, on my wall as well, so if you just look up, you'll see it. But I'm gonna introduce you to Slope Dude, who helps you remember all these different kinds of slopes. So Slope Dude looks like this, where his eyes are made up of negative and positive slopes. So I think I reversed this. Yeah, that's not negative. Let's ungroup this so I can move these around. You should be on this side, and you should be on this side. There we go. So this is Slope Dude. He's got a negative slope for an eyebrow and a positive one, so his eyes are made up of negative and positive signs. His nose is a vertical line, so at the end of his nose is a U, to stand for undefined. And his mouth, he's not very happy all the time. Like, he looks like he's having zero fun. So his little cheeks are made up of little zeros. That's Slope Dude, so he can help you remember the different kinds of slope. Okay? So you guys are going to try these on your own and tell whether the slope of the line is positive, negative, zero, or undefined. Okay? And you can just write it next to the letter. And you can abbreviate it if you want, too. Okay, so that one you're going to try on your own. You can either do it now and pause the video or come back to it. It's up to you. We're going to move on to example 1. So example 1 is to plot the points and draw a line through the points without actually calculating the slope. So we're not going to do rise or run or anything. We're just going to tell if the slope is positive, negative, zero, or undefined based on the direction that it's going. Okay, so I plot the points, just plotting normal ordered pairs. Negative 2, 5 is right here. And negative 6, negative 1 is right here. I'm going to go ahead and draw my line. Now, lines should have arrows on the end of it. As you can see, I don't have one that has arrows on both. Oh, I do. I'll just do it in this green dotted thing, but yours should be solid. So I'm going to draw my line. Yeah, I'll draw it this way. Here's my line, and then I'm going to adjust it so I can go from one end to the other, maybe. Because a line keeps going, so we're going to keep drawing it until we hit the edge. So yours is just going to be, make it a solid line going between. Okay, and that's my line. Now, looking at this, it looks like I'd be going up a roller coaster, so that's a positive slope. So that's what we go ahead and write in, positive. Okay. Now this one, I go ahead and plot. I got 0, 8, so when x is 0, right here, y is 8, right there, and negative 4, 8, so x is negative 4, y is negative 8. Draw my line. So I'm going to draw a line right here. So that is a horizontal line, which means it has a 0 slope. Okay, and this last one, I got negative 4, 7, which is right here, and 1, negative 3, which is right here. So I draw my line. I might have to adjust it some. Yeah, I'll have to adjust it so it's just a little bit taller. There we go. So this one looks like I'm going down a roller coaster. So that one would be negative. Okay? Negative slope right there. Okay? So those are the different kinds of slope. Now, finding slope from a graph, it's just, we're going to do the rise or run part. So we're just going to do rise or run. So we start at either point, it doesn't really matter. Okay? I always start on the left. That's just me though. So first thing I want to do is my rise, so I end up going up 1. When I go up, it's a positive motion, so that's why it's going to be plus 1. And then I end up going to the right 4. No, yeah, 4. So, because I went to the right, that's a positive motion as well. Okay, so I end up getting 1/4 as my rise over run, and it's already simplified, so that's my slope. Now, if you wanted to go from point A to point B, what you'd end up doing is you'd be going down 1, because you're going down, that's a negative 1, and then you go to the left 4, and left is a negative as well, so that would be negative 4. So you'd end up getting negative 1 over negative 4, which you'd have to simplify, which would just be positive 1/4. So you'd get the same thing no matter where you start and where you end. Okay? As long as you simplify. So you're going to try this one on your own. Okay? So again, you're still doing rise over run for this. And you go ahead and just do rise over run. So depending on where you start, and not depending on where you start, no matter where you start, you still get the same thing once you simplify. Another way to help you make sure you're right is that you could just look at the line. This one, for example 2, is a positive slope, so I knew my answer should be positive. This one is not a positive slope, so look at that, figure out what kind of slope it should be, and then calculate it so you have that kind of slope. Okay? We're going to move on to example 3, which asks you to find the line that passes through the following ordered pairs. So, 2 ways you could do it. One way you are more than welcome to do is graphing these two and doing it just like example 2. The other way is to use this formula, y2 minus y1 over x2 minus x1. This formula is used a lot in algebra, so if you want to start practicing it, you are more than welcome to. Okay. When in doubt though, just graph it and do rise over run. So here's the formula. I'm going to go ahead and label my point. Now it doesn't matter which one's your first point and which one's your second. It's up to you. So I just went ahead and labeled it like, maybe like this. That's supposed to be showing up, but it's not, because it's really annoying. There we go. So I labeled this one my first point. So the negative 1 is my x1, the 2 is my y1. Did it for the other one, which again is also really annoying that it doesn't want to work. So let's try that. There we go. And this was my second point, so x2, y2. So I'm going to plug that into this formula. So y2 was 5 minus y1, which is 2. x2 was 3 minus whatever x1 was, which is negative 1. Okay? Notice how everything's in parentheses. That way I don't mess up on these negatives. So these double negatives actually turn into a positive, meaning I have 3 plus 1. So 5 minus 2 is 3, and 3 plus 1 is 4. 3/4 is what I get for my slope. I don't need to simplify it, so that is my answer. You guys can try this way on your own, or you can go, if you feel more comfortable just graphing it, you are more than welcome to do it that way as well. Okay? So try these two on your own, see what you like. Example 4 is kind of a real world problem. Find the slope of the portable skateboard ramp that rises 15 inches for every horizontal change of 54 inches. Now if you look at it, it's going down, so it's going to be a negative slope. So the rise is 15. The run of it is 54 inches. So we have a negative 15 over 54. That's the rise, run, and it's supposed to be negative. Now, this is not simplified, so I must simplify it. 15 and 54 are both divisible by 3, so I go ahead and divide them both by 3. I still have that negative out front. 15 divided by 3 gives me 5. 54 divided by 3 gives me 18. That is in simplest form, so that is my answer. Negative 5 over 18. Alright? So now that you've worked with slope a little bit, we can start applying it to other things that we did in our notes from day 3 specifically. So we're going to actually graph this equation. Okay? And we're going to do the same thing that we did before. Alright? So we have the x values, we're going to plug them in for the x here. So I go ahead and take negative 1, plug it in, so I get 5 times negative 1 gives me negative 5, plus 2, I end up getting negative 3, that's my y. So I do that for all of them. This one I get y equals 2. Oop. This one, 5 times 1 gives me 5, plus 2 gives me 7, and then 5 times 2 gives me 10, plus 2 gives me 12. So that's supposed to be a 12. Please. I put in 12. Forgot to change that. So, I'm going to go ahead and plot these points now. Okay? So, I plot negative 1, negative 3, which is right here. I plot 0, 2 right here. 1, 7 right here. And then I can't actually plot 2, 12 because 12 is not on this graph, so that's okay. Now I can go ahead and draw my line, and I'll draw the same kind of line going through all 3 points, except yours is going to be solid, not dotted. Why is it not? Oh, it's really annoying when it does that. Okay, so I want to talk about this equation though. Okay, in this equation, we have 2 right here. We also have 2 here. 2 is our y-intercept, and that's always the number that's being added to x, or subtracted from x. That gives you your y-intercept. The other number, the 5, tells you your slope. So from point A, from this point to this point, I end up going up 5 and over 1, which I get 5 over 1, which simplifies to 5. So this equation tells me a lot about my graph. Once you guys get more comfortable with it, especially in algebra, you won't even make tables anymore to graph it. You'll just go ahead, oh, I got my y-intercept, I have my slope, I have enough to graph. Okay? So you guys are going to try this one on your own, and it asks you a couple of questions that we just talked about, so you can kind of see how these numbers work. But basically, these equations are written in slope-intercept form. Y equals some number times x plus some other number. That number being multiplied with x is your slope, and the number being added or subtracted to your x is your y-intercept. This is an algebra topic, so they're not going to ask you any questions on this, but I think it's very helpful for you guys to know. It's going to make your life a little bit easier. And this will eventually be on the wall somewhere in the room. Okay? So now, knowing that, it's a lot easier to find our slope and our y-intercept from an equation. So example 6, they ask you to fill in the blank, so we need our slope. Well, the slope is the number next to the x, so that's 2/3. And then the y-intercept is the number being added or subtracted to the x, and that would be the -1. So if it's subtracted, we have to include it as a negative. So -1 is our y-intercept. That's all we do. Now, if there's nothing being added to x, we just say +0 then, okay? If there's nothing being multiplied with x, we just put a 1 there, that invisible 1. So there always is a slope and a y-intercept for equations that are written like this, okay? The next example, oh, you guys are trying this one on your own, don't forget. So example 7, we have to graph these using the y-intercept and the slope. So when we're given a slope and a y-intercept, or an equation, we always want to plot the y-intercept first, because that's the only point they gave us. So we plot the y-intercept of 4, when y is 4, and then we use the slope, rise over run, to get our next point. So that means it's a +1, so I go up 1, and it's a +2, so I go to the right 2. That's my next point. I only need 2 points to graph a line. So I go ahead and draw my line, and I'm going to fix it so it goes everywhere. Cool. And there's my line. Okay, so you guys are going to try 2 on your own. I'm going to give you a hint. If you have a slope that's just one number, you can always, oop, not that, delete, oh, cool, didn't even show. I can always put a number over 1. So, if I just do it over 1, I now have a rise and a run, okay? So you guys go ahead and try these 2 on your own and see how the graphing comes out. Alright, and the last thing I need to tell you about are special cases. Special cases are basically vertical and horizontal lines, and they will show up, but it's basically you need to know what kind of slope it has. You don't have to worry about trying to write an equation, but it helps you, this will help you remember what it looks like, okay? And the way we remember it is Hoivux. So this is actually already on the wall in my room. Hoivux stands for horizontal lines have 0 slope, and their equations look like y equals a number, where all the ordered pairs have the same y's, and all the x's are different, okay? The Vux part stands for vertical lines have undefined slopes, and their equations look like x equals a number, where all the x's are the same and the y's are different for their points, okay? So knowing that, when you see an x equals a number, you're drawing a vertical line. When you see y equals a number, you're drawing a horizontal line, okay? So those are your special cases. So let's do this last example, where we just have to graph the equation again. So again, we're just going to use the y-intercept and the slope. So here is my y-intercept. I'm going to plot that point first of 1, so that's right here. And then this guy is my slope, so I'm going to plot that next. So that means it's -2/5. I can go down 2 and to the right 5, because that would be -2 over +5. I could keep going down 2 and over 5. That'll eventually take me off the graph. Or I could just reverse the sign, so move this negative to the bottom and make it a +2 over -5, gives me a point there, which still makes the same line, okay? So you could reverse the signs of the rise and the run and go in the opposite direction and still make your line. Alright? So you guys try these 2 on your own. One is a special case, so pay attention to that. Alright? If you have any questions, write them down on the side and we will go over it next class. Again, apologize for the long video, but it is an important topic. Alright? I will see you next class. Bye.